You know, those gizmos and gadgets that we use at our home with our phones or our computers aren't limited to those environments. In fact, ODOT is learning how to put high-tech to work on the roads.
To make the whole system work, you have to have the design and the related data. You have to have the machine that's hooked up to computers and sonic systems and all the GPS control and robotic total station control. And then you have to have a way to position it. So you got the design, the piece of machinery, and the positioning systems. And it does work. It works very well, it's very accurate, and that's what this is all about today.
GPS, Global Positioning System, may soon become the norm for positioning road graders, bulldozers, and more at construction projects along our highways. And ODOT has set out to learn how useful that technology can be for saving time and money, beginning at a demo project set up in the Willamette Valley.
The main thing that goes on here is that you create 3D models. And so what happens is equipment then becomes able to read directly from the design of the engineers, and the equipment is guided in 3 dimensions.
That high-tech gear, specifically GPS and other positioning technologies helping cars on the road today, is going to be helping ODOT build roads for the future. Here on the ground, earth movers and their operators go about what looks like ordinary road building. But up in space, a team of 8 to 12 American and Russian satellites are doing a lot of the heavy lifting to control what takes place thousands of miles below, 12,000 miles below, in fact.
What it allows us to do now is to go stakeless. We don't have to put stakes on the job anymore because the machine knows where it is according to the plan.
What you can't see is the tremendous amount of radio communication that's taking place. The GPS sensors and robotic total stations talk to the 3D model that's been fed into the computer aboard the earth mover, and the earth mover talks back constantly and accurately.
Well, we have a GPS receiver on the machine that receives the signal from the base station, and then we have a slope sensor on the machine that gives us our slope, that controls the slope of the blade, and it's run through the hydraulics of the machine. We have a control box in each machine, and on the control box it shows the operator where he is on the job site. Gives him all his line work, all his contours, so he knows where he is on the job at all times.
So back on the ground, how do the operators feel about using rocket science in their road graders?
I've been running grader for over 20 years, and this is my 2nd year with the GPS system, and I don't know if I could totally go back to the old way anymore.
I think it's totally the way of the future. It's technology, it's what's going to happen. And basically what's going to come down to is if you don't have it, you're going to be behind the 8 ball. It is definitely the way that things are moving.
And what might ODOT get out of using this GPS 3D construction process? Well, ODOT has been sufficiently impressed with it that graders on the US 97 Lava Butte project south of Bend and other projects have already put it to work.